Without further ado, Joe. Applause.
Thank you. The only person presenting from a Windows machine today, I think. Oh well. Yeah, hi everybody. Thank you so much for your patience while I set up. My name is Joe, and I am a developer advocate at Ably. Hopefully some of you have seen the Ably stickers around. I'm very proud of them, so please pick them up. Ably is a pub/sub messaging platform that allows developers like yourselves to build apps and websites that have some sort of real-time experience in them. And this is becoming super important to us as we've all been remote for ages and we're doing a lot of sort of shared experiences online. So what I'm going to talk about today is building a multiplayer game with pub/sub messaging and with Vue.js. But before we dive into the tech, how are you all doing? You had a nice day? I hope you're doing well, and I hope you're all coping with coming out of lockdown and social distancing and all the stress that we've been going through recently, because it's been pretty tough. It's been like actually super tough. And not being able to see friends and family as easily as we used to. We've all gotten used to these bizarre kind of remote ways of socializing. And one of the ways that I've been socializing with friends recently is playing online multiplayer games. And when, back in the before times, I used to host a tabletop role-playing game. And I really missed those nights, so I tried to sort of recreate the experience. And I tried out Tabletop Simulator. I don't know if any of you have tried it. I tried Jackbox to play like fun party games. But I kept running into snags while I was trying to play these things with my friends. Like, to play Tabletop Simulator, everybody had to go through the process of installing Tabletop Simulator, and they had to sign up for a Stream account and download and install the game. And sometimes just explaining them through that setup was enough to make them go, nah, I can't be bothered, can we just chat? And to play Jackbox, we had to have one person streaming their session over video so that everyone else could play remotely, which took a lot of technical setup. And again, everyone was occasionally just like, oh, it's not working. Can we just not? And people struggled, they got frustrated and gave up, which isn't the experience that I wanted when I just wanted to hang out with my friends and play some fun games. And I wanted something that would give a similar experience to having all of us sat around the table. So I wanted to build a game that everybody could pick up really easily and play without needing to install anything themselves or having to sign up for anything. And we've all got browsers installed on our machines, so let's build something in the browser. These days, browsers are incredibly feature-packed and capable, so shouldn't be a problem. So what are we going to build? Well, first of all, it needs to be something that's got a simple set of rules that we can easily describe in code, something that my friends can pick up easily, that has a nice, simple UI. And the lovely thing is that most board games are just a set of rules and systems that the player moves through as the game progresses. And turn-based games like Pictionary or Scrabble or even, noughts and crosses are not only easy to learn, but they're really easy to describe. If I asked you to describe the rules to somebody, you could do it in a few steps. We can write these rules down as logical steps that the player needs to take. And if you think about it, a board game and its component pieces are just a system. And all computer games really is also a system. It's a set of rules which are captured in code that then apply to some sort of state as the game changes. And the nice thing about board games, especially the simpler ones like Pictionary or Noughts and Crosses, is that you can see the game mutating as the turns progress. When somebody, for example, passes a card to another person, that's an event. When somebody places a tile in Scrabble, they're mutating the state of the board. And party games, especially, our Scrabbles and our Noughts and Crosses, rely on players being able to maintain the rules in their head, so they have to be fairly simple, easy to describe. The logic will be easy for us to write. And board games are a nice example of a computer science concept called state management, which is basically just how information is flowing through the system. And so the game that we're going to be building today is it's kind of like a cross between Telephone, which is the American name for what we in the UK call Chinese whispers, but we don't call it that anymore, and Pictionary. So the idea is that you have 4+ players, and each one has a pen and paper. So here's our players, and we'll number them 1, 2, 3, and 4. And each player is given a prompt to draw from, so a piece of text on a card that they have to illustrate. So let's do a round from player 1's point of view. So player 1 got a prompt that said, abducted by a butterfly, and this is what they drew. They then passed their drawing on to player 2, who has to write a caption for the drawing that they can see. That caption is then passed on to player 3, who has to draw from the caption that they got, and their drawing is then passed on to player 4, who has to write a caption based on that drawing. And if there's more than 4 players, we keep passing it on throughout the phases of the game until it reaches the final player. And then we reveal the whole stack to all of the players, and we laugh at how ridiculously the original prompt has transmuted and how terrible we all are at drawing. So this is the game that we'll be building today. And if we were to write out the rules of the game, they would look something like this. I don't know if any of you can read that from where you are. But what we're going to do is we're going to split up each of these rules into a game phase. So this is what each phase is what we're going to move through as the game plays through. So these first 3, where we deal out the cards, where we create a game where players join, and then when they've all joined, we start the game. That is going to be the setup phase. Then when we've done the setup phase, then we're in the dealing phase, where each player gets a card with a prompt on it. Then what we do is we're going to start a timer for 180 seconds, and each player has to draw something. And they can submit their drawing before 180 seconds is up, but once that 180 seconds is up, their drawing gets submitted automatically. This is to stop players from being able to stall the game as they're playing. Then we pass all the drawings on to the next player in the game, and then each player is given 180 seconds to write their caption out. Again, they can submit it early, but if they haven't submitted it by 180 seconds, the round will either take what they've typed or it'll take the original caption so that we can continue the game in the case that they've dropped out or forgotten or passed out, I don't know. So we collect the captions and we pass them on, and this repeats until each player gets their original stack back, and then we show each player their stacks and ask them to vote on their favorite drawings. So what we've done now is we've converted the things that the players are doing physically into state and events. And to capture this as code, what we're going to need is somewhere to store that state and some code which we're going to execute every time the game causes the state to change. So we're going to build a state machine which is going to execute the game. And then we need a way to share this state between multiple machines so that each player stays up to date as the game progresses. And in traditional multiplayer games, you'd expect this to be handled by some sort of server. But all we have right now is a browser. So the question emerges, can we build this kind of game that would normally require some sort of central server using just client-side code? And the answer is yes, we can, using something called peer-to-peer networking. You might have seen this written as P2P. And this refers to a network of computers that share and exchange data or workloads. And in terms of our game, these computers or peers are all going to send messages to each other to control the state of the game. This is different from client-server architecture, where one central computer is maintaining the state of the game and sending messages out to the other machines. Peer-to-peer doesn't need a central server, which is great. But it does need a host machine, and this is the one that is going to, for example, create the game for all the other clients to join. And a lot of games are actually built using peer-to-peer networking, including a lot of strategy games and sports games. And conversely, the majority of things like first-person shooters and MMOs use client-server architecture. So let's have a look at some of the pros and cons of each. So the biggest pro of peer-to-peer is that we don't need a central server, so we don't have to pay for a central server, we don't have to pay for hosting of that anywhere, we don't have to worry about its maintenance or its uptime. And it's a nice, simple, and effective way to manage communication between a small number of machines. Like this works really well for the number of players that we've got here, which is going to be like maximum 10. But there are some points that we should consider. For example, if you're building a game that requires a sort of drop-in, drop-out kind of playing type, that is more difficult to implement with P2P because you need to catch them up with the state. It's just more complicated. The more complicated your game is and the larger the state is with all the different things that change, P2P is maybe not the option for you. And then making sure that the game plays out identically on everybody's machine is also difficult. So if one person has a crappy internet connection or a slower processor, they're going to hold up the game for everybody. And the way that people usually get around this is just putting in a nice bit of animation, just to make it look like something is happening, like a beautiful loader, for example. And the final issue is with the way that the game synchronizes. So in order for this to work, it's necessary for all of the players to start at the same time. So if the game has started and somebody wants to join, it just isn't really going to work with the way that we're building this. But that's fine, because that's not really how you play Pictionary, so we're fine. So we've abstracted the game into a series of phases. We've got deal, draw, collect, et cetera, and we have a way of networking, which is going to be P2P. So now we need a way for the browsers to communicate with each other as the state changes in real time. And the way that I'm sure many of you have done real-time communication in the web before is with WebSockets. And WebSockets are the protocol which allows browsers to communicate in real time. So you open up a connection between the two browsers and you do a security handshake, and then you're able to send data between the two machines. And unlike REST, the connection stays open, so we can send data in actual real time. But WebSockets come with a whole bunch of extra configuration decisions for us to make for things like what happens if a user drops out? How do we reconnect them? How do we store and resend the messages that they missed if they get reconnected? How do we ensure that the messages are arriving in the correct order? What happens if there are multiple games happening at once? How do we separate them out in some way? And there are a load of different libraries available that will help you do this, and services, a lot of different options out there. But I work at Ably, and I have the entire of the Ably ecosystem at my disposal, so I use their service, and obviously I think it's pretty great. They're a service built on top of WebSockets, and it comes with all of those things managed for you out of the box, so you don't have to make those decisions. The reconnection will happen automatically, messages will always arrive in order. Just takes all that thought off your brain. And Ably uses something called the pub-sub pattern to send messages between machines. And pub-sub stands for publish and subscribe, which is a method that uses things called channels for message exchange. So users publish messages to the channel, and all of the peers can subscribe and get those messages as they're sent. And Ably is then the message broker, which is sending and receiving the messages. And the data that we're sending is just binary data, so we can send whatever we want. We're going to send JSON because it's half stack and we're all front-end developers. And we can create a JSON structure for each phase of the game, and each phase is going to have a message type, which indicates which phase it's for, and a payload, which is the data that we're going to send. And by sending and receiving these messages, we're keeping each peer in sync with the progress of the game. So let's say, for example, we wanted to send a message when a player submitted a caption. We'd first create a channel with a unique name for each game. So each game has its own channel That's how we keep games separate. We're going to connect to that channel and use Ably's get method here. Maybe I need to be down here so you can see. And other players are going to subscribe to and action that when it arrives. And this is basically the foundation of the entire architecture for which this game is going to work. So now we need to decide what we're going to build the game in. And we're in a browser, so of course it's going to be HTML, CSS, and JavaScript, but maybe a framework could help us out here. And I decided to build this game in Vue.js. I'd used it once before on a similar project, and I kind of enjoyed it. It's got very approachable documentation and resources, and I just found the barrier to entry like a lot lower than that of some other frameworks. And I didn't want the overheads of the other frameworks, so the bigger payload, the build tools, complex build steps. And the nice thing about Vue is you can use it with a single include. So I used plain old HTML to build out the Vue components, and it was a fairly simple implementation. So if you've not seen Vue before, this is what it looks like. So what we're doing here is we're finding an element with an ID of app in the markup. And then what Vue will do is it will treat any elements that are inside that as elements that could possibly contain Vue directives. And Vue directives are just extra attributes that we write on our HTML elements that will allow us to manipulate the HTML based on the application's state. So Vue makes these properties and data objects available to bind into your markup, such as the sort of greeting that is available here in this example. And when data changes, it'll re-render the parts of the UI that are bound to that particular piece of data. And Vue exposes a whole bunch of methods which can be used to implement things like click handlers and callbacks. So for example, like this do something function that we've got here. And our corresponding HTML would look like this. So you should see here Vue's VIF directive. What it'll do is it'll only display this display greeting if the data property is true. And you can see Vue's data binding syntax here to show the actual greeting. And I think it's quite nice and simple. And Vue makes it really easy to make this sort of data-driven components with our favorite HTML. So I created a separate component for each part of the game, and I've made a few screenshots of them here. So we have a game creation form, and we have a invite other players form, and then we have a canvas for actually drawing on with a few different pen colors, and a display the picture and write a caption for it. So let's talk let's talk about how the game is actually built. So the Vue app is in the root of our app directory, which is going to deal with all of the user interactions. The game is defined as a set of cards and handlers along with our state machine. And the P2P directory that you can see here contains all of the message sending code and handling code that the game needs. So let's then take a look at the Vue components themselves. So to capture the logic of the game, we need to break the phases of the game into different handlers that are going to represent the logic portion of the game and the logic that handles input during that specific game phase. So this implementation is kind of part state machine, part command pattern handler. And so what happens here is the game state machine takes the game definition, which is comprised of the steps that need to be done and an optional context model that's going to manage how those steps are executed. It expects every game to have a start handler and an end handler, so we'll know when the game started and ended. And then the constructor will take the steps and the context and save them within itself. So we have a state machine which keeps track of the current step key, which is the string that you use to define your steps. And then it also keeps track of time, so it's going to count our 180 seconds. It's going to await the execute function of the start handler, so it's going to start the game, and it's going to evaluate the response that it gets back. And once a response from the current handler has been received, the current step key is going to tick up one, and if the current step key becomes the end handler, then it's going to return because the game is concluded. Otherwise, the current step key is going to become the transition to response, which will change the current active state of the game to whatever the next game phase is, and run again and again and again until we get through the entire game. And our game logic is encoded as a series of handlers which are configured in our game state machine. And each handler represents a single phase of the game, like dealing the cards, or asking for users to send drawings, or asking users to give captions. And so this is what the entry point of the game looks like. So what it does is it references all of the game handlers and returns the game definition needed to actually create a game. And we're going to pass an ably connection inside the handler context here. And the game is defined as a series of named handlers. So we have, as I mentioned, we have the start handler, we have the end handler, we have the deal handler, we have the get user drawing handler. And each of these handlers are imported from their own handlers.js files. And each handler has access to an ably channel. And the browser of the host player keeps track of where each of the game hands are and then publishes messages out to each of the peers to tell them what phase of the game we're in. And the handlers are interesting because they do two things. They run some logic, but they also collect input from other players. So when we connect to the game using ably, the messages that arrive over the ably channels are going to get routed to the active handler for the current game phase and passed to the handle input function. And so, as I mentioned, we have all of these handlers. I've sort of described what each of the handlers do, and I'm sure you can sort of work out what each one does, so I'm not going to go through them. But the interesting thing about the handlers is that we're using async await and an unresolved promise. And what that does is it pauses the execution while the game is waiting for user input. So it means it's possible to represent a control flow linearly while we're waiting for messages to arrive over the ably channel. So say we're waiting for a single player to finish a drawing. We know that we need, say we've got 5 players in the game, we know we need 5 players worth of inputs before we can move on to the next phase. The promise we write won't return true until the number of drawings have been submitted that is the same as the number of players that we expect. And the input handler will slowly increment the this.submitted each time a message is received until it hits that number, and then the promise will resolve and the game can move on. And let's just talk a little bit about the UI. So I wanted the game to be mobile first. So I had to make sure that I had enough space for players to draw with their fingers. And I wanted it to be nice and clear and obvious how to play without having to describe the rules to somebody. So I did mock up a UI using Balsamic, but I didn't realize it was a free account and I've lost all my work. But the game phases map nicely to separate components, which is why I really love Vue and building this in Vue. And you can see the names of the components here, or maybe you can. But just to briefly illustrate, so we've got the create game form here, we've got a drawable canvas element and a timer bar and a playfield caption. So this is the playfield caption, which you can see there. And we're using our Vue bindings to change which component is showing when. This approach of only displaying whatever it is that the last message asks for makes for a really pleasant way to build up a UI. And I just really enjoyed using Vue for this. So one of the, I'd say probably the most interesting component of this whole game is the drawable canvas component. And this is an integration of two different things. It's an NPM package called Snake Canvas, which was built for a digital whiteboard product that I made a while back, and a Vue component that consumes this NPM package and adds some other methods so that events can be raised when a user finishes their drawing. And what the Snake Canvas does is it takes any old canvas element on the page, it adds a whole bunch of click handlers for drawing and for pen changing color, that kind of thing. And it gives the ability to create a palette of colors. And so to use it in Vue, I just added a div to my Vue template with a generated ID, and it creates a drawable canvas for me. So if you want to check out Snake Canvas, you can do. It is an NPM package. And finally, I needed to save images, and this is sort of one of the more nuanced pieces of building the game. All of the communication done between the peers is done using Ably messages, but messages, peer-to-peer pub/sub messages aren't really made for sending images, they're made for sending binary data or text. And even if you're going to compress your image down really tiny, it's still going to be quite a lot bigger than what pub/sub was really designed for. So what I did with the images is I used Azure's static web apps to host the game. So I used Azure Blob Storage to host the images, which returns me a URL, which I can then send in the message instead of trying to send the image itself. And then, so finally, once we've done the drawing, the captioning, the drawing and the captioning, we have the scoring round, which is really nice and simple because it's just built on top of all the other pieces. We already have a component which is going to display the card stacks, and the state machine already has the ability to wait for user input. So all we needed to do was show them every single card in the stack and wait until they voted on their favorite one. So this is an example of a scoring round that a friend of mine sent after playing the game. And so what we do is we show each player's name. I've blurred them here for privacy, and you can click and they'll get a point. And the game will collect up the points and it'll show a scorecard at the end to see who's won. And that is the entirety of the game. That's how you build a multiplayer game in Vue.js with pub/sub messaging and peer-to-peer architecture. If you would like to try it out, it's fully open source. Take it and make it your own. Like, make any game you would like from it. The lovely thing about peer-to-peer is that it really could be used to make any game that you can think of in this sort of party game genre. Let's remake the entire of Jackbox in the web. And if you do build a game, I'd love to see what you make. You can tweet me at thisisjoefrank on Twitter. And now, if we have time, do we have time? I would love to play around with the game. If I can get 6 volunteers, and if I can bribe you, I have some swag for the winners. So I have some beautiful Ably socks and an Ably hoodie. So who would like to play a version of Depict It with me? Go on, yeah. Lovely, 1, 2, 3, lovely. Okay, so I'm gonna put a URL up. You have to visit this URL. I'm gonna let one more person join. Okay, let's go. You could tell I'm excellent at art, yeah? And so this is my nice animation that we play to show that stuff is happening while everybody else finishes their beautiful pieces of artwork. Oh no, we lost you. So what will happen is, so the game will wait till 180 seconds and you'll just submit nothing, unfortunately. but you can still have a pair of socks. 180 seconds feels like a long time when you're standing up the front of a room. I can see people still drawing. Yeah, yeah.
So after this game, we're going to have a short break. Dylan, the other Dylan, is going to set up and start playing some music, and then do a talk after his music, and then we'll finish out with Mina doing her algorithmic music performance. And then, again, we'll head out of here and go to the after party if you want, or call it a day. It's been about a minute, and 180 seconds is 3 minutes. Yeah. Drawful gives you 60 seconds, I think. They're real bastards that way. Dylan, if you want to come start setting up in parallel. Yes. Parallelization.
Maybe we can have a game after.
The after party. All right.
I'm going to blame the bad Wi-Fi and not my...
When in doubt, blame the Wi-Fi. Yeah. Oh.
180. What is this, audience? Lesson learned: for demos, reduce this to 30 seconds. You also see the downside of P2P when if somebody drops out, you can't come back in.
Well, like, done and off the stage.
Two more rounds, I promise. Then you get Dylan's dulcet tones. Other Dylan, sorry. Huh? Yeah. Oh. Yeah, you can tell from how good I am at drawing on the screen, yeah? Who's still going, who's still creating beautiful artwork for us. Yeah. But the other round seemed faster, the caption round.
What's the USP of Able over GCP and AWS?
So it depends how much engineering you want to do yourself. So the lovely thing about Ably is it's out of the box. It's a lot of the hard decisions are made for you, and we've got all the infrastructure built for the sort of reliability and the scalability side. So we're based on AWS infrastructure, so we're everywhere around the entire world, fully scalable. It just takes a lot of engineering decisions away from your team, which a lot of people enjoy. Yeah, does anybody have any other questions while we wait? Did everybody get Ably stickers? Hooray. Yeah. Oh. All right. Oh. 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 I have to thank all of you for being mature and not drawing something not safe for work. I think you should all give yourselves a pat on the back for that.
Apparently not enough for that frisbees.
Pretty quickly, there's no function, so I can leave it to you for the next one.
Yeah.
That's how awful Java was as well. No one do. It's cool.
I did have to build in a special delete button for my t-shirt in case anybody managed to draw something not safe for work onto it. Sorry, Dylan. Sorry, Dylan, the other. How am I supposed to draw this? Yes, I am good at anatomy, you can tell. What has happened here? That should have been the last round? Was that 5 rounds?
Online training with AHA slides quizzes where you get 30 seconds, but as soon as everyone's answered, it stops.
Yeah.
And there's always somebody who, just for whatever reason, they can't push their own phone. And so everyone else is like, well, you answered like 28 seconds ago, and there they go. I'm like, what is it about technology? You get some a large number of people, and there's one person who the internet just doesn't work. You're like,
I truly believe it's the job for the servers or not.
Just when I feel like giving up every time is when it's finally worked.
Did you find the video out?
not yet.
Oh, I forgot I had the clicker.
Like, you're not used to it, so.
Come on, game. Come on, come on, come on. Hooray! All right, audience, we have to vote. Which one's the best one? 1, 2, 3, 4, or 5? I think 5 is pretty good. All right. Everybody else who played gets to vote. If you don't want to vote, I'm going to move the vote forwards. Votes for a winner? 4 has done pretty well. Oh my goodness. Exploding cuckoo clock. Somebody made a good attempt. Well done, Robert. My face is on fire, and also there is a kite here. Oh my goodness, that's a beautiful exploding cuckoo clock. I think number 5 has to win here. This is actual artwork. Lost in a ball pit. Who's winning? I think 1 might have it. Who's winning? Two? Come on. All right. It looks like Chris W. has won the hoodie. Where is Chris W.? Yay, Chris W. And everyone else who played, come grab a pair of socks. Thank you so much for listening to me today. I'm sorry that lasted for ages. But just to say, Ably is hiring. Come and work with me.